In terms of what's happening in memory, you can think of an unordered set or an unordered multiset as just being like this bag or cloud of values where duplicates are not allowed in the unordered set, but they are allowed in the unordered multiset. Here we have multiple 5s and multiple 2s. We talked back in FC1 about how hash tables are typically implemented using something like a vector of lists, or as we're showing it here, a vector of forward lists. There will be a hashing function that takes the value and converts that into an integer subscript within this vector of lists, and then we take a look at the list starting at that particular index to see whether the value that we're after exists in the unordered set or not. Now, just as we have unordered sets and multisets, we also have unordered maps and unordered multi-maps, where in the case of a map, once again we have a pair of values, that is, a key associated with some value, and the rule for an unordered map is that you're not allowed to have any duplicate keys. Okay, so if we take a look at how an unordered map is implemented, we can think of this as being like a bag or a cloud of keys associated with values. Each key is only allowed to exist one time, but values may occur multiple times. So here we have the key 2 associated with the value little a, and likewise we have the key 5 associated with the value little a. As with unordered set, we can use the plus plus operator on an iterator to step through each of the values that exists in the unordered map until we hit the end, which means that we've gone through all of the values in the unordered map, and there's no minus minus that we can use on our iterator. In an unordered multi-map, again, we're storing key value pairs, but you can have a given key occurring multiple times. Okay, so there are 5 standard sequence containers: vector, dec, list, array, and forward list. There are 4 associative containers: set, multiset, map, and multimap. And there are 4 unordered or hash table containers: unordered set, unordered multiset, unordered map, and unordered multimap. So altogether that gives us 13 standard kinds of containers with different kinds of trade-offs in terms of flexibility, convenience of access to elements, and the search time for elements. There are many differences among the 13 different container types, but there are also remarkably many similarities, and you can get an awful lot of mileage out of these different containers by learning a basic set of capabilities. We're going to take a look at some examples of this now for the rest of this lecture. On slide 26, we have a legend for various tokens and symbols that appear on tables that we're going to be looking at. I'm not going to read through those. I hope they'll be self-evident as we look at the examples. Here on slide 27, we're showing construction operations that most of the containers have in common, as well as some size-related operations. In this table, I've left out array. Because array is fixed size, it's very limited in terms of capabilities, and so we would end up having a column for array that's cluttered up with things that you can't do. So instead, we've got 12 columns in each of these tables. The first 4 columns are for sequence containers: vector, dec, list, and forward list. The next 4 columns are for associative or tree containers: set, multiset, map, and multimap. And the final 4 columns for the unordered containers: unordered set, unordered multiset, unordered map, and unordered multimap. Alright, so the top 2/3 of this table shows various ways that we can construct these containers. We have a default constructor where you simply give the name that you want your container object to have, and it will be properly constructed to be empty. Then we have a copy constructor that you can use to make a container as a copy of another container of the same kind. So that is, you could make a vector of int as a copy of another vector of int. You could make a list of care as a copy of another list of care, and so on. You can use the equal sign, which will also do implicit copy construction. One of the most flexible kinds of construction is this next one, where we specify iterators for the beginning and end of some sequence that we want to use to initialize the elements of the container that we're constructing. Now, what's really cool about this is we can use this constructor to build some new container of some type from any other kind of container of that same type. So, for example, we could use this constructor to build a vector of int containing all of the elements from the beginning to the end in a list of int, or in a set of int, or in a multiset of int, and so on. We can construct objects using the initialization list notation, either with or without the equal sign. The initialization list notation, recall, is a list of values contained in curly braces and separated with commas. That kind of construction works for all of these different container classes. Let's take a look at several examples of these constructors being used. We're going to take a look at this very long program in a file named containertest.cpp to illustrate all these various functions that we're talking about in these tables. So, here on slide 28 we have the very top of containertest.cpp, and we've pulled in all of the headers for all of the standard template library container types. The first thing we're doing in main is we're using bool alpha to make sure that if we're going to display Boolean values, that they're displayed to the screen as the words true and false rather than the integer values 1 and 0. Okay, so that slide is just preliminary stuff. We're not really doing anything yet. On slide 29, we have examples in which we're constructing the 4 different kinds of sequence containers, and we're also constructing set, multiset, unordered set, and unordered multiset to illustrate several of these constructors. In particular, we're constructing the following container objects: v1 and v2, which are vectors, d1 and d2, which are decs, lc is a list, flc is a forward list, and then we have s1, ms1, us1, and ums1, which are a set, a multiset, an unordered set, and an unordered multiset, respectively. After we have constructed each of these objects, then, on slide 30, we're going to use range for loops to quickly display the elements stored in these various containers. Alright, and then the output from the range for loops is shown on slide 31. Okay, so again, let me back up to the table for a moment. And what we're doing here is we're looking at examples of these various forms of constructor for all these various kinds of container. And by using the range for loops, we're going to see what the contents of those containers are. So let's go through those one by one. Alright, so starting with the code on slide 29, let me erase my highlighting, and we're going to start with v1. So v1 is using the form of constructor that takes an initialization list. We've done this before. v1 is a vector of care, and it's initialized with 12 chars, HELLO, comma, space, WORLD. v2 is also a vector of care, and here we're using the copy constructor so that v2 is a copy of v1. Now, d1 is a dec of care, and we can store the same characters into d1 that v1 contains by using the iterator style of constructor. We specify v1.begin and v1.end as the arguments to the constructor, and so d1 is now created and initialized with the same 12 characters in the same order as they occur in v1. d2 is a dec of chars, and we're simply using the alternate form of implicit copy construction with the equal sign instead of the parentheses.